Welcome back to CCNA2. We're going to talk about Module 6, Ether Channel. We're going to talk about Ether Channel operation in this video. And we're going to talk about how to configure Ether Channel. And we're going to talk about verifying and troubleshooting Ether Channel by using our show commands. Right? Always remember those awesome show commands. So, Ether Channel operation. We're going to really have these two goals, or at least one of these goals, either redundancy or increased bandwidth, that is going to drive us to using Ether Channel. Now, if you remember, we can have link redundancy with spanning tree, but spanning tree is going to disable those additional links. So with Ether Channel, we can actually keep those additional links alive, and the money we spent on maybe SFPs or port density in our switches, we can utilize that while having that redundancy. We can also have increased bandwidth. Ether Channel will aggregate or combine multiple physical links into a single logical link. So our Ether Channel interface is going to be physically a bundle of links, several links, but logically, when we go to do our configuration, it's going to be one link. It's going to be seen by by spanning tree as one single link. Ether Channel can increase speed between switches, maybe between a switch and a firewall, between a switch and a server. Some special devices will allow that as well. It just depends on your environment and your equipment. Ether Channel was originally developed by Cisco, but then it was turned into an open source, open standard, and the standard is LACP, whereas Cisco has a proprietary PAGP. So when an Ether channel is configured, the resulting virtual interface is called a port channel. So some people still call them Ether channels or link aggregations or something like that, but Cisco calls them port channels. So if you're asked on a test, it's a port channel. Spanning tree would treat these two links without Ether channel, where we would have one link blocked and we would waste all of that bandwidth unless it is failed over to. So a port channel is configured just like an interface, except for it's going to be called an Ether channel interface instead of maybe fast Ethernet or gigabit Ethernet. And of course, we can bundle multiple interfaces. So in this case, maybe two 1 gigabit per second links into a single 2 gigabit per second uplink. Now, you won't be able to use 100% of that speed on one session, but you get the point. It's actually mostly efficient, and you probably can use most of it. However, you usually don't actually end up using all of it. You might max out one without the other. So when the Ether channel is configured, the resulting virtual interface is called a port channel, right? We talked about that. We may call it an uplink. Usually you would have an Ether channel on an uplink to another switch, right? Again, same thing, bundling 1 gigabit per second links together, 2 gigabit per second. Ether channel is going to rely on existing switch ports, mitigating the need to upgrade to a faster and more expensive switch. So for example, maybe you have a 1 gig switch and you have 48 ports, and then you have some maybe 10 gig uplinks, 10 gig over here. Well, if you take one of these, well, once you have 10 interfaces that are fully utilizing their, well, most of the time it's not the case, but say they're using their entire 1 gig, per device. So you've got 10 ports full and you're using 10 gigs of bandwidth. Well, now what happens when you add an 11th device? Well, they're going to get throttled. They're not going to have that full speed with only one 10 gig uplink. So we can put the second 10 gig uplink into an Ether channel with it, and then that way we can get theoretically up to 20 gigabits per second of speed, etc., right? So you can use 4 of them and get 40 gigs, etc., depending on how many ports you have on your switch. Now, this is oftentimes a better solution than going to upgrade to a switch with, say, 25 gig uplinks. That can be much more expensive with a vendor like Cisco. So we do some kind of load balancing. Now, usually this has to do with either the source or destination, either MAC address or IP address, depending on how you configure it. It's not exactly perfect, but for the most part, it does do pretty well. Spanning tree is going to see an Ether channel as one logical link, so the individual ports are all available to use at the same time. Multiple port channels can be used for additional redundancy, but spanning tree will block the redundant path, aka the redundant channel, right? So if you have 2 port groups to go to the same uplink switch,
you will have one of those port channels disabled by spanning tree, assuming you're running spanning tree, which I hope you are. If not, you would create a loop, and that'd be a problem. Same instance if you had 3 switches, right? Our typical 3-switch diagram. If you had ether channel here and an ether channel here, one of these ether channels would be disabled, right? Can't make a loop. So provides redundancy because we have several physical connections and one logical one. Loss of one physical link does not create a change in the spanning tree topology, right? Spanning tree only looks at the ether channel interfaces, not the physical interfaces in that ether channel. And so it will not have to do a spanning tree recalculation in the case of one link failing out of a bundle. Interface types cannot be mixed. Very, very important. So if it's gigabit, you have to use gigabit with gigabit, fast Ethernet with fast Ethernet. Don't mix those. We can have up to 8 compatibly configured Ethernet ports for this port channel with full duplex up to 800 megabits per second, right? For 8 ports if we're using fast Ethernet, or 8 gigabits per second if we're using gigabit Ethernet. Now, one thing to note, while you can only have 8 active, you can actually have up to 16 links. And here's a source if you want that. It's not actually in the book, I don't think, that particular part. So up to 16 links can be configured. However, 8 can be active at one time. So if one of those 8 active links fails, another one will pick up. This is really important if, say, you have the need for 8 gigabits per second all the time. And so you put 9 interfaces to have one spare ready to pick up if for some reason another interface dies. The 2960 layer 2 switch currently supports up to 6 ether channels. So 6 bundles. So if you have the example of, say, we have a limit of 8 active interfaces in a port channel. So if we put 8 interfaces into 6 ether channels, then we will have a total of 8 interfaces times 6 ether channels, 8 interfaces per ether channel. Then we would have a total of 48 ports, and we would maximize out all ports. So if you need more ether channels than that, then you're probably going to have to go with a little bit more of an expensive switch other than the 2960. You might want to look at a chassis switch or something else other than a 2960. Now, 2960 is kind of an old model at this point. You probably won't be buying those, but just something to keep in mind. But it may differ by model. All configurations on all ports on both ends must be consistent. So keep that in mind. You want to be very, very specific with what you configure on these interfaces. They all have to be consistent on both sides. So on Cisco switches, we can either set them statically by using the on command, or we can have a negotiation protocol. There's 2 of these: port aggregation protocol, which is Cisco, and link aggregation protocol, which is an open standard. We have to make sure they're compatible, consistent across both ends of the link. So if we have LACP on one end, we cannot put PAGP on the other end and expect it to work. So PAGP is proprietary, like I mentioned a few times. It's going to send these PAGP packets every 30 seconds. And so every time we have an Ethernet channel capable port, we're going to send every 30 seconds a PAGP message, assuming we have it configured. And then, of course, we manage link additions and failures between those 2 switches. We're assuming its switches could be firewalls or something else. Now, I'm not entirely sure if PAGP is supported by Cisco's ASAs. I haven't looked, but I do know I've had issues in the past where a Cisco wireless controller did not support a dynamic protocol. I had to do a static ether channel in the past. Now, that was a very long time ago, but you may run into that. Just keep that in mind. Usually these are really for switch to switch 90% of the time. Now, operation of PAGP, we're going to have different negotiation modes. We're going to have really just desirable and auto. And I like to use the analogy of dancing. So when you go out dancing, at least partner dancing, not hip hop dancing or anything like that, you'll go, and typically the men are assumed they're going to go and ask the women to dance. Well, maybe a woman would ask a man to dance, but it's not super common. But either way, someone has to get up and ask the other person to dance. Maybe the other person is shy.
they don't want to go and ask someone to dance, but they're willing to dance. They're happy to dance. They just don't want to go and have to ask somebody. So this is kind of how PAGP and LECP, they work very similarly, are going to work. So you have to have one side as desirable. Now the other side can be desirable or auto. It doesn't matter if they ask them to dance, because if you both ask each other to dance at the same time, well, obviously everything's good. You'll create a wonderful ether channel dance. But if only one asks, you can also, and the other side is not necessarily going to ask, but is happy to dance, then you will create an ether channel. Now, if there's one side that's on or both sides are auto, you see, I know I have screens, my face is over that other auto here, auto. Then it will not create an ether channel. Very, very similarly, LACP is an open standard, 802.3 AD, very, very similar to PAGP. We have active and passive instead of dynamic, or desirable and auto. So active takes the place of desirable and passive takes the place of auto. Same idea, right? Two people are dancing, two people want to dance, or I'm terrible at this. Two people are at a place for dancing, and one can ask the other. They can both ask each other at the same time. Either way, you'll create a ether channel. But if one is on the on setting, or no negotiation, just static ether channel, or if they're both passive, this is passive, then it will not form an ether channel. Pretty simple. One of the ways I like to remember this is lap. So a lot of times I will see a question that says something like, this ether channel is configured to be active. What protocol is being used when the ether channel is configured as active? And so by remembering this, LACP uses active and passive, and PAGP uses auto and desirable. So if you remember this, then you'll say, oh, LACP has active and passive. Because they work very, very similarly, but they have different verbiage. And so you have to remember which verbiage goes with which protocol, because if you do maybe active and auto, well, you would have an issue, right? There'd be two different protocols. You would not create an ether channel. So that's all for 6.1. Join me in 6.2 as we talk about configuring ether channel, what it's going to look like in our Cisco CLI, and I will see you then.